Warm greeting you all. I am Rohini Priya, CSE department from Kamaraj College of Engineering and Technology. Now I am going to take a topic as a process management. Before the process management, what is a OS? OS is an operating system. What's the meaning of operating system? It is an interaction between user and hardware is called a operating system. What is a kernel? Kernel means it is the interaction between the software and hardware. It's called a kernel. It is a part of the OS or the heart of the OS. Okay. What is now my topic is a process management. Okay. What is a process? Process is a program in execution state is called a process. Okay, it have a passive entity and also you have a active entity. Okay, process have a memory in a space structure. Okay, so this is a memory space structure. So it have a some blocks. Okay, so first one is called a text section, second data, third heap. This in the empty space is a counter, fourth one is a last one is a stack. Okay, so first one is a text section. Text section means it is a C program coding. For example, now I am taking a C program means my original coding is called a text section. Okay, the next one is a data. Data is a global declaration section. Okay, so it's have a block of global declaration values in here. Okay, the next one is a heap. Heap means it's a dynamic memory allocation section. Okay, so it is containing a dynamic memory allocation stores in a values. Okay, the next one is a counter. Counter is a current activity of the registers. Okay, so register address what now what the address is here and what will be the next one and what will be the next one. So this is stored in this section, this counter. Okay, then last one is a stack. Stack means it's a local variable section. That means it's a function parameters and then function calls. So that is stored in a stack section. Okay, then next one is a process state. Okay, so what is a process state? So this is a diagram for the process. Okay, so first one is a new. What is new? New means it is a execution is the first stage. Okay, it is the process is a begin to created. Okay, the next one is a running stage. Okay, so before the running stage it's the process is going to the new, after going to the ready state. Okay, so ready state means it's a waiting to be assigned a processor. Okay, then next one is a running state. It is a instruction to execute it. Okay, the next one is a waiting stage. Okay, if any processes is running before the comes it's going to the waiting stage. Okay, so this is a waiting for the some enter into the occurs. Okay, the next one is a terminated. Okay, so ready stage after the terminated. Terminated means it's a finishing to the execution. Okay, this is called a process state. Okay, so in this waiting section, it's have a two scheduling algorithms is used to allocate the memories to allocate the process into the running stage. Okay, so first one is a CPU scheduling algorithm. It have a two type. First one is a FCFS, then second was the SJF. Okay, so FCFS means first come first serve. Okay, second one is SJF, shortest job first. Okay, okay, then now we are going to see about the one sum like a FCFS. Okay, scheduling algorithm. Okay, so first one is a FCFS, first come first serve sum. Okay, so with the arrival time. Okay, so first one, so this is a sum process ID, the next one arrival ID, arrival time, then next one burst time. Okay, this is a sum. So sum is to calculate average waiting time and turnaround time. Okay, this is a sum. Okay, so process ID we have a four processes. Okay, so P1, so arrival time is 0, burst time is 2. So P2, P3, P4, arrival time 1, 3, 2, 4, 5, 6. Okay, this is my sum. Okay. Okay, then so next step it's going to calculate the waiting time and turnaround time. It is my sum. Okay, so first next step starting with step 1. Okay, so first we draw the Gantt chart. What is a Gantt chart? Gantt chart is illustrating the process, which one is a starting and which one is a ending time of the process. Okay, this is called a Gantt chart. Okay, so first we draw the Gantt chart. Okay, so it is start from 0. 0 is called a arrival time. Okay, so arrival time starting from a 0. So which process is starting arrival time from 0? So we identify which one is starting arrival 0. P1 process is have a arrival time 0. Okay. So now we are going to see here P1 process is arrived. Okay. So that means the process, it's a task going to be processed. So P1 process first entering into the task to process. Okay. Then what is the burst time? Burst time means it is the ending time of process completion. It's called a burst time. Okay. So arrival time means starting time. Burst time means it's the ending time. Okay. So arrival time 0 we enter and burst time 2. So appo 0 plus 2 is 2. Okay. Then next one, which process? This is a step 1. Okay. Then next step 2. So which process going to start about a 2 arrival time? Okay. So which one is 2? So before 2 we have a P2 1. Okay. So but this process is coming from here. Okay. So burst time is 4. So here 2 plus 4. So already burst time finishing with 2. So now P2 process finishing with 4. So here 2 plus 4 is equal to 6. Okay. Then next step 3. Step 3. So then which one is smallest arrival time? What is the smallest arrival time? P4 is a 2. So now we are entering P4 here. So last burst time is 6 plus P4 burst time is 6. 6 plus 6, 12. Okay. Then next, which one is the smallest burst time? Smallest arrival time? P3. So here like P3. So last burst time is 12. Then P3 burst time is 5. Totally 17. So this is my overall Gantt chart. So finishing the Gantt chart. Okay. So after the Gantt chart, we find the waiting time and turnaround time. First we draw the one table. We draw one table. Here process ID, arrival ID, arrival time, burst time, then next completion time, which process is going to be end. Okay. Then next one turnaround time, TAT. Okay. Last one is a waiting time. Okay. Turnaround time. Turnaround time is formula is CT minus AT. Okay. So waiting time formula is turnaround time minus burst time. It's a formula. Okay. So going to be finished. Okay. So we write a process names P1, P2, P3, P4. Then arrival time. So already given 1, 2, 3, 2. Then next one burst time. Burst time already given 2, 4, 5 and 6. Okay. So then next one is a CT, completion time. So how to write a completion time? So that is used for the Gantt chart. Okay. So here this is a number, this is our Gantt chart. Okay. So here P1 process ending with which number going to be right. Okay. So P1 ending with 2. So completion time is 2. Okay. Do you understand what I am saying? Then P2 process. P2 process ending with 6. So completion time is 6. Then next one P3 process ended time is 17. So completed with 17. Completed time 17. Then next last one is a P4 process end with the 12. So last one is 12. Okay. So now we are right to completion time. Okay. Then next one is a finding a turnaround time. Turnaround time formula. What is the turnaround time formula? Completion time minus arrival time. Okay. That is. Okay. So here P1 process have a CT. Completion time is 2. Arrival time is 0. 2 minus 0, 2. Then next P2 process completed time is 6. Arrival time is 1. 6 minus 1, 5. Then P3 process arrival completed time is 17. Arrival 13. 17 minus 3 is equal to 14. P4 process 12 minus 2 is a 10. This is a turnaround time. Okay. Then final one is a waiting time. To calculate the waiting time. Okay, waiting time formula is the turnaround time minus burst time. Okay, so turnaround time is already finded, so minus burst time. Okay, so turnaround time, P1 process have a 2 minus burst time 2 minus 2 0. Then next P2 process turnaround time 5 minus burst time 4 1. Next 14 minus 5 is 9. So last 10 minus 6 4. So this is a turnaround time and waiting time. So we calculate our sum is average turnaround time and waiting time. So adding average turnaround time is equal to